Congruence. The big thing that we need to remember for congruence is we are talking about objects that are the same size and same shape. Same size, same shape. Same size, same shape. Yes, I have repeated it a couple of times. Yes, it is very important. We want to recognize that congruence is same size, same shape. So thinking of that, which transformations have we learned result in congruent figures? In other words, the size of the shape does not change. Well, we did translations first. Translation simply moved a figure left or right, up or down. Never changed the size of the shape, never changed its shape. All right, we did rotations next. All right, rotations rotated an object around the origin on the coordinate plane, either clockwise or counterclockwise. And then finally we did reflections. And reflections simply were a mirror image of a shape into another quadrant. In other words, we were reflecting over the X or Y axis. Didn't change the shape, didn't change the size. Now the symbol notation we want to get used to is equal sign with a wavy line on top of it. That means congruent. This is not the first time we've seen the term or the symbol. We want to know that congruent means same size, same shape. Geometric figures are congruent if they are the same size and same shape. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. We're going to see that in a number of examples as we move forward. So right now, the important thing is that we write it down and we're familiar with the statement. Two polygons are congruent polygons if their corresponding parts are congruent. So I can tell you that two polygons are congruent, and by such you'll know that their corresponding parts are congruent, or eventually you'll get to the point where you have to prove that the corresponding parts are congruent, and thus they are congruent polygons. Now, that portion is not really until geometry, the actual course geometry that you will take your freshman year of high school. So we don't have to worry so much about that, but it's still good for us to be familiar with so that we can think about where our content is going as we progress forward. So what's congruent? You'll notice that I've done a lot of color coordinating. The color coordinating helps us to understand what parts are congruent. So we have angles that are congruent, and for the purposes here, I made the congruent angles the same color. So angle A is congruent with angle D. Angle B is congruent with angle E. Angle C is congruent with angle F. Now, generally, you're going to have a black and white piece of paper, so you will not have colors on it. So there are two ways for us to tell which angles are congruent or correspond with one another. Now, one of those ways is these little arcs that we see in the angle. And since you would recognize the arc even on a black and white piece of paper, one arc would be congruent with one arc. Two arc would be congruent and correspond with the two arcs. Three arcs would be congruent and correspond with the three arcs. So you can tell exactly what parts are equal and correspond to each other. All right, now then on the sides, notice I've got one line, two lines, three lines. The one line will correspond with the one line, the two line will correspond with the two line, the three lines will correspond with the three lines. All right, next, notice that when I go from D to E, I'm going from the one arc angle to the two arc angle through the one line side. That would be equivalent to going from A to B, from the one arc angle to the two arc angle through the one line side. So AB would correspond with DE. Order does matter. Now, we can see the same thing down here in our statement. Our statement is going to tell us that AB corresponds with DE. Notice how the order are right next to each other. Those are to tell us which parts are corresponding. So in all, we've identified that angle A is congruent with angle D, angle B is congruent with angle E, angle C is congruent with angle F because they are corresponding angles. We've also identified that segment AB is congruent with segment DE, segment BC is congruent with segment EF, and segment AC is congruent with segment DF because they are corresponding sides to the triangle. So let's try another one. Now this one tends to confuse students simply because we see all of these right angles and we must assume every angle corresponds to every angle. Well, no, that's not true. First of all, we have a statement that's given, and the statement tells us exactly which angles are corresponding with which angles. And as such, it also tells us which sides, PQ, corresponds with WX. So there is a specific order in which they correspond. What we're losing or getting confused is the what's congruent. Since all four angles are 90 degrees, all four angles are congruent with all four angles. So that is true. They are all 8 angles that are 90 degrees, simply because we have a rectangle. But now we want to get more specific. What are the corresponding angles? And so we'll end up with angle P being corresponding and congruent to angle W, angle Q being corresponding and congruent to angle X, angle R being corresponding and congruent to angle Y, angle S being corresponding and congruent to angle Z. Now we compare together the sides. So again, notice we're going from PQ to WX. And while I have them labeled in red to blue, and red to blue, we can get the order from our statement down here. So PQ, the first 2 letters, are congruent or corresponding with WX, the first 2 letters. And so from that, we can put together all of the corresponding sides that relate to this particular diagram. To name a polygon, we write the vertices in consecutive order. For example, you can name this polygon PQRS as QRSP or as SRQP. But you cannot name it as PRQS. Even though all 4 of those are vertices, you cannot label it PRQS. It just doesn't work that way. We have to work around the shape in a logical pattern. So when we write a statement such as triangle ABC is congruent to triangle DEF, you're also stating which parts are congruent. We've already talked about this. So we are stating A is congruent to D. We are stating that B is congruent to E. We are stating that C is congruent to F. We are also stating that AB is congruent to DE. We're also stating that BC is congruent to EF. And we are also stating that CA is congruent to FD. And so we can put any combination of our letters together as long as we are correctly relating them with their corresponding parts. So given that PQR is congruent to triangle STW, identify all the pairs of congruent parts. So we could start with our angles. Angle P is congruent with angle S. Angle Q is congruent with angle T. Angle R is congruent with angle W. And then we can go into labeling our congruent sides. Segment PQ is congruent with segment ST. Segment QR is congruent with segment TW. Segment RP is congruent with segment WS. All right, so given that triangle ABC is congruent to triangle DBC, we want to find the value of x. Now, I know some of you are sitting here saying, hey, Mr. Gable, it's a right angle. We can prove that it's a right angle because we have a straight line, and so both of these must be 90 degrees to add up to 180. Yes, that is true, but I want us to go ahead and at least think through the congruent parts. So, looking at our statement up here, we're saying that triangle ABC is congruent with DBC, which means that angle ABC is congruent with angle DBC. So these two angles are congruent. Well, it would also be true that angle BCA would be congruent with BCD. Now that there gives us the congruency between our two 90-degree angles, and now we can start setting up to find x. So we know that 2x minus 16 is equal to the 90-degree angle. So we will add 16 to both sides of the equation. We're left with 2x being equal to 106, where we'll divide by 2 to isolate our variable x, and x will be equal to 53. All right, given that triangle ABC is congruent to triangle DEF, I want to answer 4 questions. What is the measure of angle BAC? So we have BAC. So we're looking for this angle here. That's 60 degrees. Now, generally, when I'm given a statement, I'm going to go ahead and put in my marks so I know what angles are congruent with what. So let's start. A is congruent with D. I already put a single mark in A, so I'm going to put a single mark in D. B is congruent with E. So let's give myself 2 marks for B and 2 marks for E. C is congruent with F. So we'll do 3 marks for C, 3 marks for F. Now that we know what angles are congruent with one another, it's going to make it far easier to start answering questions. We want to know the value of x. So what do we know about our statements with x? We know that one statement is sitting in angle B, the other statement is sitting in angle E, and our image tells us that these two angles are equal to each other. So something is equal to something else because they are corresponding congruent parts. So we have a 2x plus 24 in one angle. We have a 5x plus 12 in another angle. We have set them equal to each other, and so we will now solve our equation. Subtract 2x from both sides. 24 is equal to 3x plus 12. We'll subtract 12 from both sides, and we end up with 12 being equal to 3x. Divide by 3 on both sides, and we end up with 4 equaling x. Well, that answers the question. X equals 4. Next, what is the measure of angle y? We don't have enough information yet to figure out the measure of angle y. But would it be possible to find the measure of angle ABC? Especially since we now know the value of x. Certainly. 2 times 4 is 8. 8 plus 24 is 32 degrees. So I have a 60 degree angle, a 32 degree angle, and an unknown value angle, which means we can use the triangle sum theorem to figure out the missing angle. 60 plus 32 plus my value of y would equal 180 degrees. So we have a 2-step equation. Combine our like terms. 60 and 32 Gives me 92 plus y equals 180, down to a one-step equation. Subtract 92 from both sides, and y is equal to 88, which means our measure of angle y would have to be 88 degrees. All right, and last, measure of angle z. We have z in a one arc here, so let's look at our other image to see if it gives us any information. It does. Our one arc angle is 60 degrees. So we can see how solving all of these questions stemmed from our understanding of the angle correspondence and which parts are congruent. Example 4. You have the following ordered pairs being rotated 180 degrees about the origin to create a new set of ordered pairs. Name the parts in the triangle that are congruent. Now would be a good time to pause the video, take a look at the question, and then come back and see how you did. All right, welcome back. Hopefully you noticed that there was a rotation of 180 degrees clockwise taking place. And when we do a 180 degree rotation clockwise, x comma y is going to become the opposite of x, the opposite of y. We learned that a couple of days ago, which means any ordered pair would be congruent with its opposite in order for those to be corresponding parts. So A would have to correspond with E, B would have to correspond with D, and C would have to correspond with F. Now, if it helps, you could certainly say first angle, second angle, third angle. So now I know the order to write them. Triangle A, B, C is congruent to triangle E, D, F. Now, it doesn't matter that E, D, F is not in alphabetic order. What does matter is that they are in order based on corresponding parts. One more thing before we want to name the parts that are congruent. We already named the angles. You can go on to name the sides. So AB would be congruent with ED. BC would be congruent with DF. And AC would be congruent with EF. Quick quiz. Again, pause the video. And then come back and check your work. Triangle ABC is congruent with triangle JKL, and AB is equal to 2x plus 12, and JK is equal to 4x minus 50. Find X and find AB. Well, hopefully we recognize that segment AB and segment JK are in the same positions in the statement here, which means they are corresponding parts and therefore congruent. Since they're congruent, they are equal to each other. So 2x plus 12 is AB is equal to 4x minus 50. So we can solve for x by subtracting 2x from both sides. 12 is equal to 2x minus 50. We'll add 50 to both sides. 62 is equal to 2x. And then lastly, we'll divide by 2. So x is then going to be equal to 31. Now that was part of our answer. X equals 31. Next, it said to find AB. Well, if we have an expression for AB, we can plug in the value 31 for x. So 2 times 31 plus 12. 2 times 31, well, that's 62, plus 12 equals 74. So the measure of AB is 74. We weren't given any units, so we don't know what. We could, if you wanted to, say 74 units. Next question. Given that polygon MNOP is congruent to polygon QRST, identify the congruent corresponding parts. NO segment is congruent to RS segment. Angle T, last in the list, is congruent with angle P, last in the list. Please don't put P by itself. We're talking about angles, so we want to reference that with the angle symbol. Lastly, which transformation does not result in congruent figures? Well, the very first slide identified all of the transformations that do result in congruent figures. So the one that wasn't listed was dilations. Remember that dilations grow or shrink depending on the scale factor that is applied. And so if we have a scale factor from 0 to 1, it's going to cause our image to shrink. Sorry, between 0 and 1, it will cause our image to shrink. If we have a scale factor greater than 1, then it will cause our image to grow. Thus, our image is not congruent because it would not be remaining the same size.